Hello, this is Richard and this is another tutorial on UV spectrum in combination with mechanical objects. This tutorial will be a little bit quicker, especially for the nodes setup, because we already did that in two other tutorials step by step. So I'm trying to not stress your patience that much. This is supposed to be a robot foot, and we're going to shade it and color it and scratch it and get some dirt on that one. So first of all, of course, what we are going to do is select it. Let's have a look on the mesh. I see I still got some seams, and yeah, now they're gone. It was a low poly mesh which I subdivided in simple mode to get further vertices on the flat areas without smoothing the whole mesh, so that the UV maps that are generated will deliver a better interpolation along the polygons. Of course, later on you can bake your solution, your shader, down to a single UV map and use it onto a low poly mesh again. But I like to use UV spectrum on more dense meshes for better solutions of the UV maps. So, of course, it is selected. We are going to hit map selected once we chose our parameters. And here we are. The maps are generated. As we see here, the vertex groups, and down here the UV maps are available. So right away we are going to our node setup, to the node editor. Here it is. We won't need that guy, and we want to have for our object a new material, new shader. Like before, the first thing we are doing is to check our maps, and we're doing so by using a color ramp to get the contrast and use the UV maps as input, as well as separate the different components of our UV maps. We won't see the result unless we are either choosing material, texture or rendered mode. As we are going to use combinations of different maps, it's better to directly go to render mode, because combinations won't be shown in material or texture mode. And I'm choosing the dirt map as the first. So what we're seeing now is the X component of the dirt map. It delivers some smooth gradients based on convexity. We already know that. But what we recognize right away is that the topology of the mesh is represented here. This won't be very useful for us. Let's have a look at the Y component. There, even smoother gradients, bigger gradients appear. And clearly the convexity is treated good, but the topology is also quite obvious here. Next, the dirt diverge map, Y component. Yeah, that looks good if we want to make some big dirt and age or usage of this object. So down here we could mask a material that is much more worn and used than up here. Let's have a look on the X component. Again, a good representation of the topology. But here on the rest of the mesh, this might be quite useful to mask scratches and stuff. Divergence set gives a very good solution on the middle object, but the separated elements of our object are turned black. So they're in the negative or zero value area. We would need to separate them and map them separately. Let's have a look at the Y component. Ooh, very dark, very low values. Maybe we would have to add something here like 0.5 or 0.2. We did that in another tutorial, so I won't stress it here. The flow gather delivers a very smooth solution that clearly doesn't represent the topology. So this will be our most favorite map in combination with this object. Especially here in the detailed area, it gives a very good result. I can work with this. Let's have a look at the X component. Okay. Yes. There's the contrast. And again, there's not much trouble which we're facing. We can use this map quite good. These are the smooth convexity-based gradient maps. There are additional the seams map, sorry for making this so small. There is the seams map, which is meant for image textures, the segments, which we're going to use to color our surface, and last but not least, the texture map, which is meant to map some image texture that conforms to convexity. So it will be stretched if you use UV map texture, but it will also represent the convexity in a very good way. Good. So first thing I would like to do is to color the whole surface with segments. I'm going to use constant coloring for this, and as I'm sliding through, you see how segments of the surface are separated by each other. So color by color, I can choose the right position of my slider. Left are the concave areas of the surface. I want to have some bumblebee orange yellowish color, and in the very convex areas I want to add some bluish but dark, so it looks a little mechanical, just like this. Maybe more. Yeah, I think that's good. Of course, you can use the color ramp mapped by segments in constant mode to divide different elements of your surface in order to generate an object ID texture, which you can use in other programs like Quixel. This is a very quick way to automatically divide your mesh into different segments. And as Quixel needs some input of object IDs for different materials along the object's surface, this would normally take a lot of manual work to separate your different elements of the mesh just to get an object ID map. Now let's head on to the scratches. Of course, we are going to use further maps. Let's just put this down and this up again, although we won't use it. Well, what do we want? Let's take, for example, the dirt diverge and use a color ramp to see what we're doing. I want to get a mask along the pointy edges. So dirt diverge might be a good choice for that. Of course, I have to place the contrast at the right values. And I'm going to combine this with another map. For example, the dirt map. Let's have a look how it looks like. No, we need it the other way around, but I think they're swapped already in the Y component. Yes, they are. So we are using the Y component of the dirt map. This looks very regular. Too regular in my opinion. We see the topology here, which is not really helpful. So we additionally will input a noise texture and add it to the input of the color ramp, and multiply it with a noise texture with even bigger flakes. So we need two noises. One here, which is added to our input. Before that, we need symmetric values around 0. That's why I subtract 0.5. And these symmetric values can be multiplied to get the amplitude of our variation. Multiply, add it to the input, and already you see that there is some variation. If I turn up the scale, you see how the flakes are now varying the color ramp. We might want some stretching of these flakes. Here, the amplitude, how much does it affect the color ramp? If it's 0, we will have the same result as without addition. And let's say 0.5 was good. I need another input. So let me get closer to see what's going on here in detail. The dirt map is stretching or mapping the noise structure almost parallel to the edges. We need another solution, something like this, where it's getting orthogonal to the edges, but not parallel like here. This looks very mechanic. Divergence set gives us such a solution. And flow gather as well. Flow gather is normalized. In this case it means that the flakes are quite big. If we scale them up to 250, we see how they're getting smaller and smaller. Let's make it 800, so it's more scratches again. Okay, let's turn up the amplitude and change the subtraction offset. The higher the amplitude, the more I subtract. So that I only end up with scratches and I don't have a clear line along the edge itself. That's maybe a little bit too much, but this looks like a torn edge mask. Additionally, we're going to multiply a second bigger noise texture afterwards, so that in some areas our edges will disappear, will get black. For this we will need big flakes, so a very low scale, and simply multiply it with the result of the color gradient. So what we see is that this factor doesn't really allow a lot of contrast, so we have to add it manually. So it's more like this. And here you see how we can mask different edges, whole areas of different edges, so that the edges themselves won't be completely shown, especially here in this topological area. We got rid of the obvious topology. Okay, so much for our scratch mask. You can imagine that we're going to combine the mask with two different materials, because the mask divides the paint from metal. As the more we scratch, the less paint will be there and the metal underneath will be revealed. As we're using the scratch mask as the mix factor, I'm going to choose it right away here. So what is white is now the glossy shader, and what is black in the mask is the diffuse. We have to exaggerate the factor, and I'm doing that by RGB curve, whereas simply bump up all values to the white so that the scratches are getting brighter and brighter, and therefore the mask for the metal. Okay, something like this. Or let me just first make the bump, because scratches also come with a bump of the surface. So we're going to add a bump value. That's quite quickly, and we're simply choosing our scratch mask as bump input. But as the white areas of the scratch mask should be deeper than the paint areas, I'm going to invert the mask, the bump value, and use it as input for both shaders. So clearly the scratches are better visible now. And additionally, we're going to add some dirt, especially for the paint of our robot foot. We're doing that by modifying our constant color ramp. I'm adding two sliders, left and right, of each border of the segments, and turn it back to linear. What happened now is that we get smooth gradients between the segments, but you will see how this helps in a few seconds. The middle slider, or all of the middle sliders, are now getting darker colors so that it looks like they're beveled down. We see that this one is very broad, that's between yellow and orange, so I'm simply sliding them together. And now I'm adding a slider in the middle of the segment, and at the border I want to make it look more used, so I'm desaturating the color here and make it more grayish. And right away you see what happens here. We get a color variance away from the bevel edge. If we do that everywhere, the plates that are segmented will look very used. Here as well. Darker and desaturated. And for the orange, let's choose a much more saturated orange, like this, for the middle, and at the edges again to see the effect. Darker and desaturated. Okay. It's not. I don't like the color. I think that's better. Let's move this direction. And still, I want to add more dirt, like dirty spots along the surface. So finally, I'm going to use, what do I use now? So much for this. Now I'm going to add some textures, scratch textures. Of course, only the textures that are already included in the pack. But for this, I'm simply choosing an image texture node, and I'm going to add scratch 6 dark. Let's have a look at the output. I'm going to duplicate the diffuse node now and plug it right into here. Yes, automatically chooses the seams map, but I want the texture map. This gives some variation of dark and bright areas of usage. Maybe scratch 6 dark is the wrong one. Scratch 7, yeah, that's smoother. We don't see that many scratches, especially not stretched scratches, but rather get a smooth gradient, a gray brownish gradient. And we're going to combine this image texture with a second one that is in flow gather map projection. And to combine it, I'm going to choose a mix color that is set to, let's choose lighten. How does this look? Yeah, we get some scratches all over it. But the flow gather texture, that's quite big. I want to scale it down so that I get more details and less blurry pixels. You can scale it with a mapping node, and this annoying option that the nodes are moving when you insert another one, you can disable it here. I don't know why this option even exists. It's simply just annoying. So I scale it down. I chose a scale factor of 5. So I get far more detail in the different areas now. The main color, color number 1, will be the image texture. So with the factor I can vary the input or the influence of the flow gather texture. This is very dark. We are in the middle brown or middle gray area of brightness here with this map. So every combination with the original shader we made will quite quickly darken our solution. To avoid this, I'm going to lighten it right away by using color RGB curves. Bump it up so it just gets brighter and brighter, just like this. Okay. And we're going to combine it with this shader. Of course, you can imagine that I'm going to use a mix RGB node again. And where am I going to use it? Here. With the color input of our diffuse map. it's this one. And I'm going to plug the texture map output into it. So that's that. And we don't simply want to mix it, we want to, let's try multiply it. What happens? We get some variation here. Ah, right, and we see the border here of our texture. That's from the Flow-Gather solution, because we scaled it with a factor of 5 along the horizontal axis. There is no tiling, so I should avoid scaling the x-axis. I should scale the y-axis to get more detail, and only the y-axis. Okay, so we have some variation along the surface. I guess you get the idea. You simply use the different maps for masking and the contrast by using color ramps to smoothly get some edges and scratched textures, which you can use to divide colors. The segmentation or segments map, you can use it to color your mechanical surface into different convexity-based smooth groups or convexity groups. And as I said before, you can use these segments to come up with an object ID map in use with Quixel or other softwares. So next we're going to append a ready-made shader. I guess the metal plates or metal panels, segment panels shader would be a good choice for that. To append another shader, I go to File, Append, choose the material library, go to the materials folder and look for my different metal materials. Here the panel segments or mothership, what else? Metal panels. And finally we have some metal dirt. They all use quite the same techniques, just like we did here in our custom shader. One last thing, you see that there are white spots. That's because the roughness of the glossy shader is 0. So this gives a very sharp reflection. We can avoid that by turning it up to 0.1 or even higher, so that it's just like a shiny material and not a perfect mirror reflection. Yeah? Okay. So now let's cycle through the different shaders. Panel segments. This is just like our shader we just built, using segments that are separated and used to color our surface. You can change the colors here. We have some scratch mask here, which you can change. And additionally, I'm using gray panels for greeble, which in most cases will stretch a lot. So this is better for spaceships and really complex models or complete models, not like small low poly assets. Let's have a look at the others. Well, that's just a simple gradient. Another simple gradient. Oh, that's gonna take some time because that's a very complex shader. Metal panels is meant for helmets, robots and stuff, so this should fit our robot foot quite well. With the only addition that here we have the small feature of lights. You can add some small lights in the panels. The light density is chosen here. Scale will also change density, so a higher scale will make a lot of small lights. But for now we don't need them because the foot is not that, doesn't need that many circuits and little light diodes for visual feedback. So I'm simply turning lights and intensity and the light scale down to 0, maybe to scale, not to 0. This is never a good idea to choose a scale at 0. And you see that here already, this shader already has a very good scratch structure. These scratches look very detailed and small. And they align pretty good to the mesh without showing obvious geometry topology. Okay, so of course, in order to use UV spectrum, you will use a lot of the pre-made shaders and simply modify the colors here and the values. So let's have a look at this one. We have one group node which represents the different segments. We have gotten onto the segments before with the segment gradient. This is nothing else than the gradient. So here we have the color and here is the position of the slider. Only that this group node is quite complex and gives also very good edge output, height output, and a gray mask for bump usage. So the output here is very good for metal plates that really simulate plates that are scratched. And another shader is the metal panels. We just had them. It almost looks exactly the same as the shader we made ourselves. Again, it has a nice scratch value where you could really use the material, use in the way of, in the sense of usage. So it's torn down and scratched down. The mothership is a textured shader. It has different groups, node groups, each containing the nodes for different elements, like the lights. You see that there are some lights in the concave areas. You can choose some parameters here. The textures that are used to make the greeble along the surface, which aligns almost perfectly to the surface, but on the other hand is stretched. Therefore, you can choose all the image textures here and their mappings here. Panels have different colors, which you can choose here. Bump that up, so these colors are multiplied over the textures. That's why they are still quite dark, although I chose quite bright colors. Of course, you could use another blending mode like overlay and stuff like that. Well, where's the output? Here it is. This is overlaid. This is not. So you can just play with all these nodes yourself to alter and modify the shader setup itself. But mainly you will be happy with the setup as it is. So I think this is my most favorite, but also my most favorite transformer is Bumblebee. So of course the yellow shader is my most favorite shader here. yeah, I hope you enjoyed the tutorial and you've seen some of the use of the UV Spectrum add-on. I'd like to hear your feedback. If you have any questions, just feel free to ask me. Thanks for watching. Happy blending and see you next time. Bye.